All right. Welcome, everybody. Uh, I'm recording this special video to basically go over the hashing homework. And in particular, I'll be focusing on the hash tree because that has, a lot of details involved, like why it is useful and just going through the code um, and, how to make that work, like implement it, right? So that's why I think making a video will be helpful. So if you're stuck, if you need extra hints, then this video should help. So I'll make it to the point. And once you see this video and your answers are also not, your questions are also not answered, then you email me, ask questions in class, right? Attend the office hours. I'll also be having evening office hours because that's convenient for some of you. All right, so let's dig in. All right. So this is related to problem number 3, which introduces cryptographic hashing. Okay, and then uses the concept of cryptographic hashing to build a tree of hash codes. And the reason to do that is for efficiency purpose. When you have a task of verifying if a small file out of a big file is valid or not, has a particular data been modified or not. So the basic idea of cryptographic hashing is if you have a large file and you break it down into small chunks, then each chunk could be hashed, and then you build a hash tree from the leaves, right? So this falls into divide and conquer. So building a hash tree is basically a divide and conquer task. All right, so let me first start with the motivation, and then I'll go to the code, and finally I will talk about how to implement it. Okay, so that's the idea. So just to get motivation, you'll go to Merkle Tree. So Merkle Tree Wikipedia page has a nice picture which is helpful for me to explain the concepts. Okay, so if you take a look at my what I'm showing over here, let's say that your file has been split up into 4 chunks or 4 data blocks. For example, if your file is uh, 10 megabytes, then each of these data blocks is 2.5 megabytes. So 2.5, 2.5, 2.5, 2.5. So in total, 10 megabytes. So if you have to send this 10 megabytes of data, then you can actually send them in pieces. So 4 data blocks could be sent. Now, when you send, the data could be corrupted in the middle, uh, or it could be modified. I mean, some hacker could change it. And what we want is secure transmission of data. So some data is sensitive, you want to transfer it securely. And you want to verify if the data that you receive at the other end is the data that was sent. Okay, so typically what happens is hashing is used and cryptographic hashing is used. So each of these blocks is hashed. So hash 00 is a hash of L1. You do a cryptographic hash, and that's what you get in hash L2. For L3, you get hash of L3, and for L4, you do a hashing function, and you get L4. And then you could do a tree. So you basically concatenate the 2 hash codes that you get. So it's like a string concatenation. And on the concatenated string, you do a hash again, and then you get the root. So root is the hash of these 2 children. So finally, you get, about 40 characters as the top hash, which is at the root. It's also called root hash. So that's the concept, right? So if I give you 4 files, then you have to create a root hash or a top hash. So you have to apply this hash function level by level in this fashion. Okay, so this is what divide and conquer does. So just think about, I had discussed one program where you had to find what is the maximum of 4 numbers. So then there was a divide and conquer program for FindMax. So this question was also asked in the exam, to write an algorithm for FindMax. So it's the same idea. The code has the same structure. So that's why I call it divide and conquer. All right, so this is the, this is a basic Merkle tree. Now, if you read this document, then it will provide you some knowledge about that this tree is very popular, and Bitcoin also uses it, but there are other software that uses it. And basically, this overview section talks about, how the verification is done for a given data block. So I'll just give you an example of the verification. So let's say L3 is the block that your machine has received. So how do you verify whether L3 is correct, or is it corrupt? Has it been modified? How do you do that? So what a computer will do following this Merkle tree scheme is that it will first apply, given that there are other computers that have created, I mean the source computers, they have created this Merkle tree already, and then the source machine is sending you the data, and you have to verify whether data is correct or not, and you have received L3. So how do you verify the correctness? So what you'll do, your machine will basically do a hash on this data block, and for the remaining hashes, it will ask the other machines for help. So other machines will provide it this hash 11, and when this is provided, then your machine can calculate this hash 1, right? It will concatenate and do find this hash 1, and then your machine will also ask the network of computers to give you hash 0. So the source node has already built a Merkle tree, so it will give you hash 0. So once hash 0 is there, then you can calculate top hash. So your machine has built a top hash. Now this top hash will be compared with a trusted source or trusted server. So a trusted server which your machine trusts, you'll basically verify the trusted top hash with the top hash that you received. And if this L3 was not corrupted, then the top hashes will basically be the same. If this data was corrupted, then the hash code would be different. So the top hash will also be different. So just by comparing the top hashes, there is a mismatch between the trusted top hash and the top hash that you have built, your machine has built, and that's the way you know that L3 is corrupted. So what does your machine do? It will ask for this data block from some other source. So it will keep doing that. So doing this in a tree-wise fashion is very optimal, is very efficient, because given a data block, you could verify if it's correct or not by just doing log n hashes. So you go from the leaf level and you go up to the root. So the depth of this tree is logarithmic because it's a binary tree, log n to the base 2. So this is very efficient. Now, if you have done hashing in a linear fashion, to verify a particular data block, you have to do all the hashes together, and that is order n. So for each block verification, you basically have to do the calculation of hashing for all the blocks. So it is called order n. So however many data blocks you have to go through all of them and do hashing one by one, and that's order n. Doing that with a tree is log n. So that's fast, right? Now, these are all details related to the motivation, right? Why we're building a tree. We're building a tree so that the verification is fast. So that's why, the homework question here is motivated by how do you build this tree? So that's the question, right? Okay, good. Now, how is the hashing implemented? So given a data block, how do you hash it, right? So that's the first question that you have. And I have talked about that in my class, but I'm just repeating it so that you have all the information in this video, so that watching this would actually get the things clarified. All right, so for the hash function, you can take a look at crypto hashing. So what crypto hashing does is it basically tells you how hashing works in a cryptographic sense. So this program demonstrates what is cryptographic hashing. So given an input like a cat is walking and the cat looks happy, this input you can convert it into a hash code like 40 characters big. So that's what this program will do. So if you go through this program, you will see that it is doing secure hashing and applying a standard here. And these are boilerplate code for you. The hash code is in terms of bytes. So the digest function is the one that generates the hash code. Now you can take a look at the bytes by converting into hex, converting to hex format, hexadecimal format. And this hexadecimal format you might have studied before in your hardware systems class. So if you give an array of bytes, these arrays of bytes get converted into hex decimal numbers, so 0 to 9 and A, B, C, D, E, F. So that way you can print it. If you print the same bytes as string, then you'll get a lot of non-printable characters, which basically looks like unreadable. And this happens because the right way to look at bytes is by converting them into hexadecimal. So that's the way the cryptographic hashing is used. But for convenience, it suffices to just make a string out of it and then work from there. So if you print the string, you will get some question marks, and the reason for that is because not all ASCII characters are printable. So if they're not printable, then you'll see exclamation and these characters. All right, so let's run this program. So when I run this program, a cat is walking. This sentence for this, the hash code, the cryptographic hash code is this one. Okay, so that means given any input, it will give you 40 characters, right? So if you count how many characters are there, and there is a space in between, there are 8 times 5 is 40 characters is the hash code. So this is the hash code which gets combined together to give you the root hash. All right, so this program should make sense first. The only difference in my hash files is that I'm printing, I'm not doing this conversion to hex. I'm just using the bytes. I'm converting the byte array to string for convenience. But I could have used this function for printing there also. Could have, but I did not. Okay. So cryptographic hashing is clear. All right. Now let me talk about how do we combine the two hash codes. So let me talk about that now. So the general idea is that if you have two inputs, let's say child1 hash value and child2 hash value, then you concatenate them together, right? So this is the concatenation. This plus with double quote is to treat this as a string. So this is string concatenation. And whatever you get after concatenation, you'll apply the hash function and then you'll get the hash value, right? So that's the way you combine two children. So you can think of this as parent, and then this is the child1. Just making something like a tree. Okay, so this looks like tree. So how to combine child1 and child2, where child1 and child2 are themselves hash codes. So what you do to get parent, first you concatenate the string child1 child2, the hash values, and then apply a hash function on the concatenated string. So that's the basic idea of how do you combine, because in the end we want one hash code, right? So the combination should happen in a tree-wise fashion. All right. All right, to make it concrete, I can actually give you a very concrete example of this combination. So let's say child1 hash value is this one, and child 2 hash value is something different. Let's make it D so that the child 2 hash value is different. Then the combination would be, just concatenate this string and put this double quote and then write the second string. So that's how you concatenate them, right? So you get concatenated, and now you have to apply the hash function. So do a hash function on this. So that will give you the hash code of the parent, right? So that's the basic idea. All right. So how this has to be implemented? So you are given create hash tree as the name of the method, and what it takes as input is a string of file names, and you have to return the top hash or the root hash after combining everything in a tree-like fashion. All right. Now let me go through, this program in a little bit of detail so that, this makes sense. This makes more sense. So I have provided you with this class hash files, and hash files has the first method as hash string value. So what it does is it will take an input string and then turn it into a hash code. So that's what it does. So whatever input you have, it will change it into hash code, so bytes. So that's what we saw in cryptographic hashing. So I'm using the same code. And to make the concatenation easier, I'm converting them into string. So the same bytes are getting converted into string and it's getting returned. There's some exception handling. All right. Now, the second method that I have is hash file. So if you give a file as input, like, you have a bunch of files that you have to process. So if you give a text file as input, the name, then it will, this method, what it will do is it will read that file. So there is a file input output, and it will read that as a string and then convert it into bytes and apply the digest function. The output comes as bytes, you convert that into string. So the same idea, read the file, get all the string, and convert all the string into a hash code. So no matter how big input you have, the output would be 40 characters, or 40 hexadecimal digits. If you print them in string, it will look a little bit weird, like with question mark and non-printable characters, but that's the gist. Convert a file into hash code. So the input that I've provided you, 0.txt, 1.txt, you have to think of this as there was a original file and it got split into 8 chunks. So that's the reason you're given a lot of files. So the idea is that the original file has been split up into multiple small files so that you can do hashing on each one of them. All right. Okay, good. So then I have a main method where I use the methods that I just showed you. So if you have a string, any string, you could have a sentence, you could have a password, you have a hash code, whatever you have, you invoke the hash string value that we just saw with the input, and it will give you the hash code, right? So if you run this, you'll get a hash code for this input. Now, the second thing that I'm showing you is how to basically get the top hash, combined hash, using what is called a hash list. Okay, so hash list is what I'm showing. Now, if you're interested in hash list, you can take a look at Hashlist Wikipedia, but the concept I will explain so you don't have to read this Wikipedia. So hash lists are also, known. It's a known concept, but our homework assignment, does not ask you to do list. It asks you to do tree. So that's where you will focus. But I want to show you the code for Hashlist because that will clarify what does the combination step mean, how combinations of the individual hashes are done. Okay, so here again, the input is like 1,000 data blocks. So think of this as 1,000 files. So how do you combine the hashes of all of them? So individually do hash for all of these blocks and then combine them. So concatenate hash. So combine them in that fashion. So you'll get a top hash. So no matter how big the data is, the top hash is always of size 40 characters, where each character is either a digit or a letter, alphabet. Yep. I mean digit like 0 to 9 or A, B, C, D, E, F. So hexadecimal, right? So top hash. So how this is done, I will basically show you what I have done. So hashlist method is given that I have provided you to combine hash values per file. So per file, you generate a hash code and then combine them. So basically, I first read the first text file, which is 0.txt for me. And then I go through the rest of them. So 0 is already considered. So I start my loop from 1. There are 8 inputs, so I go all the way to 8. It will stop at 7 because I is less than 8. So I read 1.txt and then use the method hash file that I showed you earlier. Reads the file, and it's also done here also. Reads the file and then returns the hash code. And I give this variable name combined hash because this is where I want to store the root hash or the top hash. So I basically convert the files into hash codes and then combine them. So how do I combine them? Well, I concatenate the two hash codes, right? So string concatenation, and then I do a hashing for the concatenated string using the method that I showed you earlier, hash string value. So I get a combined hash out of the two. But when this loop repeats, then I have a combined hash of 3 files, then combined hash of 4 files, and so on. It will stop when I have a combined hash for 8 files, and that's what I print. All right, if I had printed it as a byte array, it would have looked pretty nice, but I printed as string. All right, so here the first printout is coming from the main. So this is the printout. So what is the hash code of this password string? This is what it's showing. And the next combined hash is coming from, this method, top hash using Hashlist. So this is a Hashlist idea, like go through all the files one by one and sequentially combine them 2 at a time. Okay, so that's the printout is coming from this line number 141, which I've highlighted here. Okay, so this is a linear way of combining things, so that's why it's called a list. But how do you do that using a tree? All right. So I have gone through, the inputs programs that I've provided you, which are useful. So what you'll now do is, write the logic to do top hash. And all right, so how do we do that? So there are 2 methods. Okay, there are 2 methods to implement this. So the first method is the sketch of the code. Sketch of this code will look like FindMax. Okay, FindMax code. So let's see if I can find the FindMax code. Then I will show you that code. Let's see. Yeah, I think I got it. So is it Java? Yes, it is Java. Okay, so what FindMax does is it's a recursive divide and conquer code, right? So what happens here? You have a base case. So what should happen in a base case scenario and what should happen in a general case? So the general case is find the middle point and have two recursive calls. And then once the recursion is done, now there's nothing more to be done, so the base case is hit. Then the conquer step is to compare the two and return the result that you're interested in. And in FindMax, that is the greater number out of the two. All right. So if you want to, try to think about how your hash tree method is similar to FindMax. If you want to like do this practice, then you don't want to see my hints, okay? Because now I'll give some hints so that if you're stuck, you could do it, okay, using this divide and conquer scheme. So you may want to skip that if you want to do it yourself without the hint, okay? Which is what you should do. You know, try to think like, how is FindMax gonna help me in creating a hash tree? Okay. All right. So now let me give you an idea how this is same. So you don't want to hear it. If you want to try it yourself first. Okay. So now I'll show you, how hash tree could be done using the same idea. So in hash tree, you're always have to return the hash code after you combine them. So hash tree, and you have the list of file names. All right. So in this, the base case, if there are 8 files, then you want to split that into 4 files and 4 files. So that's the way the divide and conquer works, right? You want to, break it down into 4 files and 4 files. So split. So finding the middle point and doing the 2 recursive calls and then doing it again recursively. So that's the idea that you have from divide and conquer, right? So you'll apply that here. So these 4 files again should get decomposed into 2 files, 2 files, 2 files, 2 files. And now you can see that in the base case you have 1 file, so this 2 get broken into 1 and 1. This 2 gets broken into 1 and 1. And finally, the last 2 also gets broken down into 1 and 1. So in the leaf level, you have 1, 1, 1, 1 file. So this would be the leaf of the tree, leaf level of this tree, right? So leaf level is what the base case handles, right? So the low and high become the same number. And that's when the base case gets hit. In FindMax, you just return the number and what you can do in the base case for hash tree. All right. So now I'm giving you a hint. If you want to think about yourself, then you should pause my video and then think about, okay? Pause over. Hopefully you thought about it. So the base case could be if low, and we will also need, int low, int high. So you can add the parameters and change the code. So if low equals to high, then you basically want to read the file, read file, file names low. You could use low or high, both mean the same thing. And after you read it, you basically get a string content of that file, right? And you would basically want to do hash string value. Hash string value on the content. So that would return you the hash code. So it would return you, the string hash code of this file. All right. So how would you call this method? Well, from main, let's say you had a main method. So from main method, you would call the hash tree with the file names. So I mean, I show you how you could have read all the file names here. So this loop basically generates the file names also, right? This is how it generates the file names and then reads those files, right? So use the code similar to this. So you have file names ready using that i.txt idea where I is 0, 1, 2, 3. So file names are read, and that file names goes as the input, and low is 0, high is 7, right? How many chunks you have? So 0 to 7. So you call this method like this. It's a static method, so it would work. All right. So this is the base case. So you could read it and hash it, and you can return the hash code. All right. So this could be the base case. The general case would remain the same. The general case would remain the same. So you would basically do the split into 2 half and call call this method recursively. You can call the hash tree method recursively, and there should be 2 recursive calls, left and right. So left recursive and right recursive calls, left and right. And the basic idea is, the parameters you just adjust because you've calculated middle. So there is a left middle and then there is a right, left and right. Okay, so from low to middle is left, from middle plus 1 to high is the right. So this would be there, and I'm not like writing everything so that you have I just don't want to give away everything. And then the conquer step, right? How do you now conquer it? So there would be a hash code from the left hash code, so which would come here, and then there would be a hash code coming from the right side. All right, and then the idea is to combine. Conquer step is basically combine step, combine the hash code. So here you'll basically use left hash code, concatenate with right hash code, and this is string concatenation, and then call the hash method again here. So the hash method, so hash string value method, and this is what you can return. Okay, so that is the general idea of the divide and conquer approach of doing things. If you let the whole program run recursively, you have to fill in these, there are parameters that you have to fill in here. If you let this code run, then ultimately what will get returned is the root hash value, so which could be accepted here, and then you just print the root hash, right? So use the Java format for printing and print the root hash, right? So this is what the question asks you to do. So this is one way to implement it. If you change it a little bit, then you can also have a tree-like structure where you use the tree node class. Okay, so you could do that as well. So right now you lose the tree structure here. So verification can be done, but this tree structure could have also been maintained if we use the binary tree idea that we learned in COSC 2100. So that could also be done. So that way the whole tree is preserved and you don't lose it. Right now the internal nodes get lost when the program returns. Okay. All right. So this is the first method to do it. I told you that there are 2 methods to do it, and this is the one that uses divide and conquer recursively. But you don't need to use recursion to solve this. So I will now give you another method to do the same thing. So if this tree construction looks difficult, then the alternative method is what I'm going to describe. Okay. All right. So, and I actually covered this part for maybe 3 minutes in the class as well. So how do you do divide and conquer if you don't want to use recursion? So I'll tell you one scheme. So that scheme is you basically have a queue. So instantiate a queue. So Java provides you a queue. So you could use Java queue, or if you don't want to use Java queue, then copy paste the queue classes from your data structure class. So copy paste in your Eclipse workspace in your project, and now you'll be able to use the queue that you learned in your data structure class. Now queue is a very important class that you want to learn and you want to remember how to use it, right? And if you Google, you'll actually see in the internet how to use Java's queue. So in order to use Java queue, you have to import, import java.util star maybe, right? So that there is a import statement that is needed, and I'm commenting it because I'm not actually writing the whole code. I'm just giving you some guidelines here. So what you can do is create a queue of strings, and these are the file name queue. So create this queue. So do new on queue, and then create this queue. Then for all file names, so like insert all file names to the queue. So this is done using the enqueue method of the queue. In the data structure, we call this method enqueue method. So that is what will add something to the queue. And if you, so when you insert these file names, then the 0.txt would be the content of the queue, then 1.txt, then 2.txt. So I'm showing what the queue would look like when you insert all the file names to the queue, right? So your queue would look like this. So your file name queue will contain all of these. All right, so once you have this queue, then you can write a code something like this. So while your file name queue is not empty, and the name of the method will depend, right? You have to just look at whether it's a Java queue or whether it's a queue from your data structure class. So this is not empty. You basically have to combine a lot of time. So that's why you have a while loop. So take the basic idea that take the first two items from the queue, or here the items are file names. Take the first two file names from the queue, and then combine them, right? So you'll basically do something like file name queue.dq. In some queue implementation, this method may be called remove operation or poll operation. So this would be file name 1, and then you do a dq one more time, then you get file name 2, and now you have these two file names. So you do you basically read these files. Now you could read the file and get the string representation of the files, and you do that for the second also, and you have the second file name, and now do the hashing, right? So you have this file 1, string file 2, then invoke the hash string value method to create a hash code, and then combine them using the logic that I basically gave you here. So this is a combination of two hash codes. All right, once you have, let's say you have a combined hash code from the hash codes of file 1 and file 2, that's what you will insert it or enqueue it to the queue. So you will do file name queue dot enqueue and put the combined hash code, right? So that's the basic idea, and this is not a complete code. This is just the basic idea. What you could have done is the reading part could have gone outside the while loop as well. That would have made the programming easier. Because the next time you dequeue, then you will not get file name, you'll get actual strings. So I think the easier way to do it would have been the reading part actually goes to another loop. So you would have arranged this a little bit differently. So in a for loop, so loop over all the files, all the file names, and this is a while loop. And inside the while loop, you basically read the file and hash the file. And once you have the hash code, add the hash code to the queue. So the queue that basically I gave you. I mean, you can create a queue. So let's call it file queue or just a queue. So just let's call it a queue and add that to this queue. Queue.enqueue hash code. So that way, you know, when this loop is done, you have gone through all the files and then done hashing and put those hash code in the queue. Now your method would look nicer. So now the queue contains the hash code of all the files. So while the queue is not empty, basically take two items and combine them and then enqueue it. So the queue has, you have removed two things from the queue, but you're adding the combined thing back to the queue. Okay, so how will it look like? So let me explain how will this look like. So let's say you have a hash code for file 0 and hash code. So you basically read everything and put this in the queue. So HF2. So the queue contains hash code of file 3 and so on hash code of file 7. Right. So this is what your queue will contain after you read them and do hash coding for all of them. Now, once you have that, then you'll go through this loop. You'll take HF0 and HF1 because that's what the 2DQ operation will do, and then HF0 and HF1 are removed, and then you combine them. All right. So you combine them, concatenate them, apply the hash function, the hash string value, and then whatever the result is, let's say string result, that actually now will, this is the combined hash code, right? Let's give it the name combined hash code. So that gets added to the end, okay? The combined hash code gets added to the end. And that's what happens again, right? Then you take HF2 and HF3, that's what get concatenated. And then you get a combined hash code of HF2 and HF3, and then you write that towards the end. So this gets removed. And you have the new one towards the end of the queue. Then you pick the next two, right? You pick HF4 and HF5, do the same combined hash code and write that in the end. So when this queue, eventually the queue would have taken everything. So in the final thing that you get is the root hash. Okay, so this is the way to do it. First, read the files one by one and do the hashing and put that in a queue. And then the queue has a lot of hash code, so go over them two at a time, combine them and write that to the end of the queue. Take the next two, put that in the end of the queue. Once you're done with this while loop, you'll have a root hash. Okay, so this is the second method of doing your hash tree. So far we discussed two ways. So the first way was to do a tree using divide and conquer, which is the code looks like find max value, the tournament tree, right? So it looks like a tournament tree here. And the second approach was without using recursion, where you use a queue as a data structure to solve this problem. Okay. Okay. So far we discussed what a Merkle tree is, why do people use Merkle tree, and then I talked about cryptographic hashing, which explains the hash function that you apply on text files or any data that you have. And then I talked about how to merge these two, uh, these two parts. This is the basic idea, and then the code also I showed you here, how you combine them, right? So combination is important to understand. And then I talked about two methods, one using recursion and the other using queue to implement HashTree. So hopefully this helps you with the HashTree homework. All right, if you have any question, please let me know. So I'll stop my recording here.